Hello there people, this is Christian and welcome back to my computer and Fusion 360 and a slot pattern that is filling what you might call a rectangle here, which we can change the size of. We can do it 125mm. Did Fusion think for a while. We can change the angle 45 degrees and we can change the slot size 5. And it updates reasonably good. This is a parametric version where you can change things. I'm going to do basically two different workflows. The workflows are basically the same. The one is a bit more locked down, where we will have the same width of the slot and the spacing in between. And that we do by hand, so we need to, before we do, we need to define the size of everything. And I'll also show you how I do this parametric version if I don't screw up all the parameters, which there is a bunch of. But we will start with the most basic ones. We're going to close the parameters here and open our new sketch here. So I just simply create a plate here to work on. So we're going to use parameters to control things anyway. We're going to start with pattern width. That's the width of a pattern, and this is going to be the, we call it a circumscribed rectangle. We're going to have a look at that later. 250. We're going to do pattern height. Let's do that 135. And we need to define our slot width. Let's do 4mm. And we need a slot angle. Slot and angle. And we need to define this as degrees. Let's do it 65. I like that. Let's see if we can get this to work. So that is our basic parameter if we want to do things by hand and totally control things. And so if we're going to do this one, you need to decide before the size of a pattern, stuff like that. So we're going to create a sketch on the top of this little plate here. We're going to do a rectangle to help us define our pattern. And it's going to be the pattern height and pattern width, like that. So we have a square here, and then of course there's the placement of things, but I haven't defined that with parameters. I'm simply going to project in this corner here, as I want to lock down things and get fully defined sketches. So we're going to do a dimension from here to here. Let's do 75. We can dimension from here. This is not important. This is just me want to have a clean sketch. So this just locks down where we want it, so we can move it later if we want to. But the important are the size of a pattern. So with that, let's see. I'm going to hide the body now because it's going to go flashing around. I'm going to turn on like that. Turn on the dimension tool. And the first thing I'm going to do, I'm going to make a line. Make it a construction line from this corner to here. And make another line, not a construction line, normal line. Somewhere here, just up like that. And we're going to make the midpoint between this line and this. So it gets locked down the middle. And we're going to dimension the angle. This was our slot angle. As this is the manual way of doing it, you really don't need all the parameters. You can just sketch this and work from the sketch. But I like to use parameter to know what I do later. So let's see here now. We did that. That's the center line of a slot, and I want 2 more lines. Just gonna make lines somewhere here, a bit off, so they don't get any constraints. I'm gonna tell oops, where did you did not get connected? Coincident between that point and that line. Oops, you're flying around. Won't confusion, but this line, hold down control and select the other lines and make them parallel. And we're going to make a symmetry between this line, and here, and then add the dimension. This is of course going to be our slot width. So this is where our slot going to run. This is just to help us see things. And let's see. That's a bit boring. We're quite close together. Let's change that. Modify parameters. A bit better to see. Let's make that 45. I did this because I want to show you the angle between here. but these are not the same. This can confuse you sometimes. So we're going to make a 45-degree angled slot instead. We're going to need some points for later. So S on the keyboard, start typing in point, find point tool. We need the center point here. We're going to use an axis there later, and we want these 2 points here. These are going to be used to measure when we do the pattern. When we do it by hand, not when we do it parameters. A finished sketch. That's all we need. Yes, that's all we need. Construct plane along path. Select the center line. And the distance is going to be 0.5. We want to make it in the middle of a line. Hit OK. Create sketch on our new beautiful plane. Turn on the body. We want to do an S intersect. S on the keyboard to start searching and type intersect. And I want the body. The body what we have. Because I do not know the thickness. We're going to hide the body now. I'm going to hide that sketch there for now. The problem is we get a profile here that can be flashing and disturbing. So I'm going to mark here and hit delete on the keyboard. I don't need that line. I'm going to mark out here and type delete. So I reduce the sketch to the minimum. I'm going to turn on the sketch again. And what I need now, I want these 2 lines. I don't want the points. That's important. I'm going to do P on the keyboard for project and project in these 2. If you have a look, you can see that they're not really the same place as these points I made earlier. So do not pick up the points, pick up the lines. Like that. We're going to hide this sketch now again. And we're going to make a line from this point, straight down, this point, and straight down. We can inspect to check things. This should be our slot width. That's 4 millimeters, so that's totally correct. We're going to finish sketch, turn on the body, and turn on this sketch so we can see things. So, we have done our sketches. And now we're going to skip over to surface, do our first extrude on the outer rectangle here, or a circumscribed rectangle. I'm just going to make it symmetric and make it something like 20 millimeters, so that's protruding the body in both directions. Hit OK. And now we go back to solid. We're going to make an extrude, and we're going to find, I'm going to turn off this sketch, so I only have the last sketch we did. This profile, hold down and select the profile. And distance, we can select 2 objects, and here is important. Select the surface body over here, not inside here, because you only select one side. I want the full body, so I'm going to click on the body like that. And cut, yes please, and hit OK. Wait for fusion. I'm going to hide the surface body now because I don't want to see it anymore. For now, I'm going to hide the sketch too. Now we want to round off the corner. I'm going to S on the keyboard and fillet. And here we can use when you find a new fillet version, full round fillet. The problem is selecting the center face. Sometimes we have to be careful, so we really select that, and you can see it. Other things gets blue now. We just click here, and things fly away. But you do click side one, go in and side again, and things doesn't change. But hold down Control, and you can select the faces here. Let's see if this works. Sometimes this now it's a bit confusing here. Yeah, I got the wrong face over here. Oops. Do not fly around like that. I'm going to use my space mouse now. Get things a little bit better. So I'll select that face. Yeah, I got it correct. This can be a bit fiddly to get the right faces. You could choose the corners and do other things, but this works really good because it always maintains the full fillet. So the center face is the end of the cut, this angle, and then the side one is either side, and the side two is other one. So take your time. Don't get panic with this thing. Okay. I'm going to go back to our home view, and we have done our little first slot. I'm going to turn on the sketch again so we can see things. And you can see here now, if we look from the top, that the what I call the rectangle here, our pattern's going to stop tangent to this. So that's the limitation of our pattern. So what we're going to do now, we're going to do a rectangular pattern. So S on the keyboard and rectangular pattern, and we're going to do it on features. The features we're going to do is the extrude we did and the fillets. The direction we want is the line we have here. So we're going to do it along this diagonal here. And we want to change extent to spacing. This is the handmade, what we call it, manual version of the pattern. The good thing is when we can lock down things. The distance here, we're going to do a measure. It's going to pick up a line we did earlier, so we'll do a measure again. That's a bit confusing sometimes. I'm going to hide the body now and have a look at our sketch and use the 2 points we made here. The point here and the point here. I'm going to turn on the body gun so we can see things. Oh, come on, body on. Let's see what Fusion does for us. 4.0, yes please. We're going to make it symmetric. And I'm going to tell Fusion that this is not correct. I want it multiplied by 2. And we should have, it's a bit hard to see the pattern sometimes. We're going to now add our patterns. Can we hide the sketch to see it better? New. There's new as that. And we're going to add our patterns. I don't know why we can't see patterns sometimes. The thing here with pattern, oh, where are they? A bit hard to see. Oh, there they are. Sometimes you turn around things. The important thing is the quantity needs to be an odd number. That's because we have one cut out of the middle. So let's do that like 21. Oh, we can do more. 23. 27. Yeah, we can do more. 29. The important thing here is that we do not want the pattern to extend beyond the edge here, because we're going to do some fun things. 33. I think I stop at 31 for now. The important thing here is compute option should be adjust. Let's see if we can solve this. Hit OK. Yeah, it works. We can see it stopped here. The problem is if you do the pattern beyond here, as we do adjust rectangular pattern, which means it will redo the cut we did earlier, and the cut was stopped by the surface body. And the problem is, of course, if a pattern goes outside of a surface body, it gets really confused, Fusion. So let's see here. We had 31, so we should do 33 and see if that works. It can crash. No, it worked. So if I go one more, it will crash. We can do it. Hopefully Fusion doesn't crash. 35. And now we are outside, so we get a warning of a pattern that something is wrong, and sometimes it produces strange pattern size. So we're going to open this again and go down to 33. So this takes some manual work to get this to work. And we have a beautiful pattern. We're going to hide the sketch and have a look. So we done basically half our slots. Turn on that sketch again. What we need now, we need an axis. We're going to construct axis perpendicular to face at point. Just click the profile over top of here, and we have the middle point here, which we made earlier. This is the center of the pattern. Hit OK. We can now hide the sketch. Oh, not the body. I want to come back body. Hide sketch like that. So what I'm going to do now is I'm going to do circular pattern. Circular pattern. Once again of features, and it's going to be our extrude, our fillet, and our rectangular pattern. And the axis is going to be our little beautiful axis here. And we're going to do 2 of those, but the important compute option needs to be optimized, as far as I know. Optimize means it's basically just going to take the faces of all these cutouts and mirror them. If you try to do adjust and other things, it's try to recalculate, but it doesn't know where to fit the pattern to stuff like that. So do optimize and will mirror faces and 2 and hit OK. And am I lucky today? Yes, I'm lucky today. Let's hide the axis. And by that, we have made a pattern. We have made a beautiful little pattern. But yeah, so that's the manual version. The good thing is we do an inspect from this line to this line. We should get 4 millimeters. Once again, inspect from the metal rib. It's 3.9999. Yeah, so it's basically the slot and the rib in between here is going to have the same dimension. But let's say you want to play around, look how things work. So now let's go into the stupid and strange parameter settings. Modify, change parameters. These are the ones we are doing inputs on so far. We need all of those, yeah. Step 1. I'm going to turn on the sketch again. I'm going to hide the body for a short while. The number one we need to calculate the possible length of our pattern, and that's of course the diagonal of this little beautiful rectangle. So just do the math. There we're gonna do pattern length. The thing is, I'm going to do a symmetric pattern, so let's call it sim. So remember that's the symmetric pattern, and we're going to do some strange math here. So we're going to do a square root, Pythagoras theorem for you who remember it. We're going to do pattern, just do the height squared. The problem is now that the unit's gonna be scrapped up, so we're gonna divide this by millimeters squared through millimeters, and plus squared like that, plus pattern width squared divided by millimeters squared, and in parentheses, and we have the full length. What we calculate is the full diagonal now, and as we do a symmetric pattern, we know they need half of that, so we're going to divide it by 2. And the problem now is, if we do this as an extent of a pattern, we're going to get the pattern all the way out here, and that's going to crash Fusion, as I showed earlier, when we go outside of the square we have here, or the surface body. So I will reduce this with the slot width multiplied by 2. You can play around a bit when I know that this works good, so we're just going to adapt. If I change the slot width, it's going to knock it in a bit further or out further depending on how you change it. So that's all I need to do there. Yes, okay. So we have calculated the length we need of a pattern. Now we need to calculate number of pattern. This is going to be confusing. No units. We cannot have units in that. Let's see if I remember how I thought about this. We need to calculate how many slots we have possible to put in at this pattern length. And we need to round it down. So we're going to do floor of pattern length symmetric divided by, I'm going to start a new parenthesis here, slot width. But it's not only the slot width, we need to multiply it by 2 because we need a small rib in between. And that's 16. So in this case, it's going to want to put 16 patterns from here all the way out to here. And let's see now, the problem with this is of course that this pattern is including the one in the middle here, because when you do a pattern it includes the one you start with. So you could do -1. And let's see, am I thinking correctly here? Yeah, I think so. So this is of course the number of patterns on one side, and when we do the symmetric we need to tell it patterns on both sides. So we're going to put everything of this in a parenthesis. We're going to multiply it by 2. And when you multiply something by 2, it always ends up with a even number. And the important part about this number pattern is that it needs to be an odd number. So we add 1 and we have an odd number like that. So let's see if we can make this work. I might make a fool of myself, make everything wrong. We're going to turn our pattern, we're going to go in, we're going to back up to here and go into our rectangular pattern. So we're going to change these to extent, and the extent is going to be our pattern length, and this is going to be a number of patterns like that, and hit OK. Let's see what Fusion brings us. Yeah, it worked. And just whack it over to get it like that. Turn off our sketch. So let's see if this works. Modify, change parameters. I'm going to hide all these down here, so I only have the one I want to adapt. Let's change the angle. 60 degrees. Are you going to crash on me? Are you going to work? Yeah, we can change the angle. I want 5mm slots. It works. Or we change the dimension. It's going to be 200 meters high. And we can change it. Yes. I'm so happy the thing works. The only thing that's, of course, the problem with this way of doing it. If we do an inspect, the slot is the size I set it for, but this rib here is 4.8188 and the slot is 5. So the problem with the fully parametric is that I do not take in consideration that this should be the same width as the slot. I'm too lazy to do the math with the angles in between here, but yeah, I think it looks good. It's up to you. So you have two choices: and do it manually, and you have to decide before the size, or you're gonna crash, or you can do this little strange or stupid parametric way of doing things. So that is how I do these slots in a way, so I can do them in as little work as possible. It depends on how you see work. With that said, take care, see you around, and goodbye.